So, hello everybody, how are you all? I hope you all are fine and safe. So, today I'm welcoming you all to my new video, and in this video, I'm going to evaluate infinite series actually. And well, guys, let me tell you one interesting thing that this video, like, I'm going to evaluate an infinite series, and this is going to be the first video of mine to mine of evaluation of an infinite series. Okay, and the series is I'm gonna write it down. Yeah, okay. So let me let me just write down the series and then I'll talk to you. Okay. So I am assuming that this is S. Okay. So S is equal to the series from n equals 1 to infinity of hyperbolic sine of pi. Hyperbolic sine of pi over hyperbolic cos of, I think it's 2n pi. Okay, 2n pi and minus hyperbolic cos of pi. Okay, guys. Yeah, that's what we are going to evaluate. Okay, so like most of you, if you are in class 12th or something else, but you don't know what this hyperbolic, what does this mean. You all know that what is trig function. Yeah, right. So the like trig function we have, there are trig function like sine, cosine, tangent, and the same way we are having hyperbolic functions, and these kind of things are like sine and then h that represents hyperbolic sine. Okay, of x, and well, I have already written that the hyperbolic sine of x is equal to e to the x minus e to the negative x over 2. So it's a formula, right? And the same way of hyperbolic cosine of x, that is hyperbolic cosine of x equals e to the x plus e to the negative x over 2. And that's what we are going to use to just convert this hyperbolic terms into like exponential terms. Okay, and that's just gonna make our life easier. So I think, guys, I should begin right now because it's gonna be quite a long video. Okay, because yeah, it does look good, and we're going to evaluate it. Okay. So yeah, what the first step is to just convert this hyperbolic sine into this exponential terms and the cosine as well. Okay. So let's just do that. I think I should continue right over here. So what we can do right over here, this series from n equals 1 to infinity itself, and the hyperbolic sine evaluated at pi. Okay, just be careful of that. So we are going to replace x with pi, right? Let me just tell you right over there. Well, in both the cases, x is going to be replaced by pi, like for this and this case. Okay, and the same way we are going to replace x with 2 and pi. Well, I'll talk about it later. Okay, but for now, let's just evaluate the hyperbolic sine at pi. So it's just replace the x with pi. So we are going to have e to the pi minus e to the negative pi over 2. And the same way, we are going to have the hyperbolic cosine of pi equals e to the pi plus e to the negative pi over 2. And if I'm talking about this term, then it's quite easy, and I want you to evaluate. I want you to express this term into exponential terms. But you have to just pause the video before I'm going to tell the the new expression. Okay. So yeah, the hyperbolic cosine of 2 and pi is just e to the 2 and pi minus e to the minus 2 and pi over 2. So yeah, these three things we are going to use to convert to express our s in terms of exponents, right? And yeah, so hyperbolic sine evaluated at pi, we are going to have e to the pi minus e to the negative pi over 2. right? In the denominator we are having that, um, where, yeah, no, firstly that, right? So cosine, like hyperbolic cosine evaluated at 2 and pi is e to the 2 and pi minus plus, actually sorry, e to the minus 2 and pi over 2, right? And with negative sign we are having that, let me just write down here, e to the pi plus e to the negative pi over 2, right? In short, let me just write down again for your convenience. So in the second step, we are having that, like this, I'm gonna repeat this step again. We are having e to the pi minus e to the negative pi over 2 and over e to the 2 and pi plus e to the negative 2 and pi over 2 minus e to the pi plus e to the negative pi over 2. And if you look closely, then we are getting rid of 2 and 2's, all right. So what we are gonna left with is the s, the series from n equals 1 to infinity of e to the pi minus e to the negative pi over e to the 2 and pi plus e to the negative 2 and pi minus e to the pi plus e to the negative pi. Okay, and what next? Like we successfully have converted this expression into this, but now what? So now what we are going to do is to just multiply, like we have to multiply it with e to the 2 and pi over e to the 2 and pi. Divide, multiply and divide, okay. So now what we are going to have is, just be careful, from n equals 1 to infinity. Well, look, if you multiply this e to the 2 and pi plus e times e to the pi, then you're gonna, like, you can think that, like, let me just tell you right over here, okay. So e to the pi times e to the 2 and pi. So when base are same and if these two terms are being multiplied, then we are gonna have only the base times the addition of these two powers, okay. Pi plus 2 and pi, and you can think that we can successfully factor out a pi. So we're gonna have 2n plus 1 times pi, right? And with this, along the same way, we can just do it like all the terms, okay. And well, let me just write it down. So on in the numerator we are having that e to the 2n plus 1 pi minus e to the 2n minus 1 times pi. Like you can just think of it, like I'm not going to explain it again, okay. You just have to multiply it like this term with e to the 2 and pi, okay. And in the denominator, if you multiply this term with this, you're gonna have e to the 4 and pi, because these two terms are equal, and if they are going to multiply, they are going to be squared, right? And like being added, okay, it's not squared but being added. And if you just look at this, they are going to be cancelled out and leaving 1 minus, if you multiply these two terms, e to the, again, 2n plus 1 pi plus e to the 2n minus 1 pi. So yeah, well, I know that it looks quite ridiculous than this, but yeah, believe me guys, it's gonna help us out. So let me just release that stuff and continue with that board, right? So, and okay. So yeah, I'm just gonna copy that down. So we are having that s from n equals 1 to infinity of e to the 2n pi, sorry, 2n plus 1 times pi minus e to the 2n minus 1 times pi over, well guys, look, I just want to factor it like e to the 2n pi times e to the 2n pi. I can do that because it was being multiplied, so I can just write at, like, I can just write it at the first step. Like what I'm trying to say is, just have a look, guys. Like e to the 2 and pi times e to the 2 and pi, right? So I got to have e to the 4 and pi, but I won't want to write this e to the 4 and pi. I would like to again rewrite it as that, okay, at the first step. And I will tell you again, just be patient, guys. So we're having that e to the 2 and pi times e to the 2 and pi, okay? And we are going to have a plus 1, and then just changing the signs inside this second parenthesis. So we're going to have e to the minus e to the 2 and plus 1 times pi minus e to the 2 and minus 1 times pi, right? Okay, so what next? Okay, let me just check it out. We did that. Okay. Again, we need to like, yeah. Wait a second, guys. Just think again. Like, I just want to factor this thing. I just want to make it to able to be factored out, right? So what I'm gonna do is e to the 2 and plus 1 times pi and e to the 2 and minus 1 times pi. Well, what I did here, let me just explain right over here, okay? So I have just written e to the 2 and plus 1 times pi and e to the 2 and minus 1 times pi. So if you just look like carefully, then we are having that e to the 2 and pi times e to the pi times e to the 2 and pi and times e to the negative pi. So these things are gonna cancel out, and these two things are the same as of e to the 4 and pi. And why we are doing that? Because actually I missed it, but yeah, I have just solved that question in my laptop and or actually tablet, but send it to laptop, and I'm just watching the solutions. If I'm doing something wrong, I would get to correct it right now. So yeah, that's what I got to have. So I think you guys understood that, and we are gonna factor it out easily. That's why we are doing that. So yeah. So now what we are gonna have as the series from n equals 1 to infinity, and in the numerator we are having the same stuff, minus e to the 2 and minus 1 times pi over, and guys, just have a look. I'm just gonna factor e to the 2 and plus 1 pi with this term and this term, okay? So e to the 2 and plus 1 times pi. So from this term we are having e to the 2 and plus 1 pi itself, but from this term we are having a negative one, right? And from 1 and this term, I'm just gonna factor a negative 1. So if you look that we are gonna have like it's negative, so if I'm factoring out a negative, it's gonna be positive, it's gonna be. So we are having e to the 2 and minus 1 times pi, and that's one a positive one, so it's gonna be a negative, right? So these, wait a second. Oh, sorry, this is a negative one, okay? Because I hope you understood that I made a mistake. Yeah. So if you can see that these two sums are equal, so now we are good to go with the factorization. The series from n equals 1 to infinity of, in the numerator, same stuff is gonna get copied out, minus e to the 2 and minus 1 times pi over, we are having e to the 2 and plus 1 times pi minus 1 times e to the 2 and minus 1 pi minus 1. So far so good, I think, guys. Yeah. Okay. And now what we are gonna having in the next step is, I think I should erase these stuffs, right? Yeah. So So I'm gonna introduce a negative and positive one in the numerator, okay guys? And for factorization, for the sake of factorization, okay? So what we are having is series from n equals 1 to infinity, and I'm going to introduce e to the 2n plus 1 pi. Okay, so e to the 2n plus 1 pi minus 1 and minus e to the 2n minus 1 pi plus 1. I hope you guys understand that we are gonna cancel, we are gonna rid of, like if you're going to solve it, we will get rid of a plus and negative one. So we're just gonna left with that expression only, okay? But for the sake of factorization, we are doing so. And in the denominator, we are having e to the 2n plus 1 pi minus 1 times e to the 2n minus 1 pi minus 1. So if you look closely in the numerator, we are having that the series from n equals 1 to infinity. So e to the 2n plus 1 pi minus 1 in a bracket, and a negative 1 is commoned out. So e to the 2n minus 1 pi minus 1, right? And now we are able to just like get rid of this looking term, okay? I hope you can understand that. So 2n plus 1 pi minus 1 times e to the 2n minus 1 pi minus 1. So now if you look closely, then these two things, like I don't need to write a one over here, but I can write this summation in two summations further, and the first one would be this thing, and the second one would be this thing. So if you look closely, then we are gonna read with this thing and this thing, and we are gonna have like please guys do it something by yourself. So first term we're gonna have is e to the 2n minus 1 times pi minus 1 and minus 1 upon e to the 2n plus 1 pi minus 1. So till here guys, I want you to just recognize everything and just digest everything. If you're having any sort of problem, then you can ask me in the comment section, and we are good to go further, okay? We are ready to go further, and yeah, I can see the okay. Yeah. So next step is we are gonna multiply with e to the negative times 2 and like this term is gonna multiplied and divided by e to the negative times 2n minus 1 times pi. Okay. So we're gonna have like I'm just gonna write it down, right? But before that, let me just take a picture. Guys, yeah, so okay, and now I'm just gonna erase the stuff, okay? But before that, let me just tell you guys this. Let me just check it. Like, I hope everything is visible to you. Like, I'm writing it on whiteboard. Yeah, I think it's visible. It's visible. So I'm just gonna multiply with like e to the negative 2n minus 1 pi over 1 minus e to the negative 2n minus 1 pi. I hope you can understand that. I'm just gonna multiply with this term but with the negative power itself. Okay. So if I'm going to multiply in the numerator, we are having the same term. But if we are going to multiply in the denominator, if you multiply that term with this, so it's gonna be 1 obviously. But with 1, it's gonna be the that term only. Okay. And we are gonna repeat it with the same, but here we are having negative 1, and I will multiply with negative outside but a positive inside, okay? So e to the negative 2n plus 1 pi over 1 minus e to the negative 2n plus 1 pi. Right guys? I think so far so good. We are like moving, okay? So I think I should just erase this thing. And we're gonna move further with where's my chalk? Okay, right here. Okay. So now, guys, okay. Okay. So now I'm considering a geometric series. Okay. Yeah. So now consider a geometric. Sorry. Geometric series. And what's that? That is, okay. So e to the negative 2n. I will tell you what I'm doing right now. Okay, guys, just be patient. Just try to conclude by yourself. So it's gonna be a GP, right? Geometric series or geometric progression, okay? So I'm just gonna considering a geometric progression, okay? So now, if you look closely, then it's the sum from n equals 1 to infinity of e to the negative 2n minus 1 times pi whole to the n. And what's that? It's just the basic thing that e to the negative 2n minus 1 pi over 1 minus the same thing, 1 minus e to the negative 2n minus 1 pi. Because if you know like the formula for geometric progression, so we are having a plus ar plus ar squared plus ar cubed plus dot dot dot, and r should be less than 1. So what's this? It's just the series from n equals 1 to infinity of a r to the n, right? Well, it's from 0. So what's this? It's just 1, no, a over 1 minus r. That's what the formula is. So here we are having a is the first term. So the first term is right over here. And if you look the common difference, like common ratio, if you divide this term with first term, like the second term with first term, you're gonna have only this term, okay? Like the same as the terms inside the parenthesis, right? So r is same and a is same. That's what we did here. So I just gave you a little introduction to what is a geometric series. And in India, we study this kind of things in class 11th, okay? So if you can digest right now, then you can think that this is the same that is evaluated over there. And you can just do it for this also. So it's like this is also like this is gonna be e to the negative 2n plus 1 pi over 1 minus e to the negative 2n plus 1 pi. It's the same as the series from n equals 1 to infinity of like look, you can just put that n right over here, so we can just do that. So e to the negative n times 2. Well, I don't think that I should use n because no, it's k, guys, okay? Because we have already introduced an index variable as n, so we don't want to be fight, like I don't want to just clash over there. So yeah, k, right? K 2n plus 1 pi, right? And this is the same. So now what we're going to do is to replace this thing with this and this thing with this, right? But you will ask me that why, Aman, why do you want to introduce 2 more summations rather than we are having another outside this big thing? So just be patient, guys. I'll tell you everything. Just keep patience and okay. So And now what we are gonna have like S is the series from n equals 1 to infinity of this thing is gonna replace by this thing, right guys? So we have k equals 1 to infinity of e to the negative k times 2n minus 1 times pi, right? And this thing is again from k equals 1 to infinity of e to the negative k times 2n plus 1 pi, right? Okay, so what we did like after that, let me just write it in a proper manner. E to the negative k times 2n minus 1 pi minus k equals 1 to infinity of e to the negative k times 2n plus 1 pi, right? And now we can think that these two things are same, everyone is just going from 1 to infinity, so I can just write down it as two summations, that is for one index, for the first one is for n index variable and the second one is for k index variable, right? Okay, let me just write it down in a proper manner. So S is now k equals 1 to n, firstly the n, and then k equals 1 to infinity, and inside the parentheses you can think of that we are having these two terms, but if you look closely, okay, let me just write down first e to the negative k times 2 and minus 1 pi minus e to the negative k times 2 and plus 1 pi, right? And now that's gonna erase this board. So you can think that we can factor like the 2nk e to the minus 2nk outside, like you can just factor it out, okay? From n equals 1 to infinity and the second from k equals 1 to infinity of e to the negative 2nk, right? 2nk pi. Wait a second, guys. Okay. Minus 2nk pi. 2nk pi. Like this is gonna be e to the negative 2nk pi dot e to the k pi minus e to the negative 2nk pi dot e to the negative k pi. Right, I have explained it, like how can you factor 2nk pi from this thing, okay? So 2nk pi, and in the parentheses we are having that e to the k pi minus e to the negative k pi, right? So now we can just distribute, like how is this n equals 1 to infinity of e to the negative 2nk pi times the series from k equals 1 to infinity of e to the k pi minus e to the negative k pi, right? So now we are heading towards our ending, and again we are gonna just have what do you call it, consider another geometric series. And what's that? It's e to the negative, yeah, e to the negative 2k pi plus e to the negative 2k pi whole square plus e to the negative 2k pi whole cube plus dot dot dot, and this is gonna be expressed like this from, let's say that m equals 1 to infinity of e to the negative 2k pi, like let's say n, okay, n, because this thing is gonna multiply it with that. And what's that? Right, what's that? It's the common ratio is same and the first term is same. So this is gonna be this e to the negative 2k pi over 1 minus e to the negative 2k pi. That's the basic evaluation of a geometric series, right? So well, yeah, so that's gonna be written like that. So we can replace this thing with this, like we can replace this thing with this. Be careful, guys, to be noted, like this is gonna be replaced by this thing because both are same, like we have considered another geometric series. And now we are close to our end, but before that, let me just do it completely. Okay, and yeah, so we're having that we can replace this thing with that. So we are gonna have s equals, like I'm just gonna write this thing before everything, from k equals 1 to infinity of e to the k pi minus e to the negative k pi times, this thing is being replaced by that. So I'm just gonna write down that, okay, like this, e to the negative 2k pi over 1 minus e to the negative 2k pi. If you look closely, then what's this? I'm just gonna multiply, like I'm just gonna multiply this thing with e to the 2k pi actually, e to the 2k pi, and divide with e to the 2k pi. Well, not 2k pi actually, only k pi, right? Multiplying and divide with e to the k pi, and so on the numerator we are having, let me just write it down again, e to the k pi minus e to the negative k pi, and like this is gonna be e to the negative k pi, and in the denominator we are having that e to the k pi times 1 is e to the k pi minus e to the k pi times e to the minus 2k pi is e to the minus k pi. So if you look closely, then this thing and this is going to be cancelled out, and we are going to just leave with the simple series from k equals 1 to infinity of e to the negative k pi, right? And what's that? So it's just another infinite series, I think. E to the negative pi plus e to the negative pi whole squared plus e to the negative pi whole cubed, and plus so on to infinity. It's just a simple geometric series with a as e to the negative pi and r as another e to the negative pi. So the s is a, which is e to the negative pi, over 1 minus e to the negative pi. So, and like the rest, like I hope you understood, guys. Let me just check it. Like I hope you can see everything clearly, and let me just clear everything. I hope you guys everything is understood by yourself right now, and I'm just gonna write the last step, and I think I have to erase this. If you want to just take an like screenshot, then you can just proceed with that. I hope you guys just took it. Yeah. So this is our last step, guys. Like what we got is S as the series from k equals 1 to infinity of e to the negative k pi. So it was like e to the negative pi plus e to the negative pi whole squared plus e to the negative pi whole cube plus so on to infinity, right? So it's just a simple geometric series with the first term as e to the negative pi and the common ratio as again e to the negative pi. So the formula was like Rs is equal to a upon 1 minus r. So e to the negative pi upon 1 minus e to the negative pi, and just multiplying with e to the pi and dividing with e to the pi. So you can think that if you multiply these two things in the numerator, we are going to having 1, and if you look clearly, e to the pi times 1, e to the pi, and minus e to the pi times e to the negative pi is just 1. So finally we are having our answer as 1 upon e to the pi minus 1. So this is what that series being evaluated to. Yeah, it's kind of hard work, but yeah, I'm feeling very I'm feeling very good after solving that series, and I hope guys everything is clear to you. And if you have any sort of doubt, then you can just ask me. You are open to ask everything, anything actually. And well, this was quite good, and I loved that series, but. Yeah, I think everything is good, and just continue your mathematics journey, guys, because it's kind of very lovely. Like, wow, mathematics is like wow, and what else? We did that, and I think I should just cut out right now. And well, guys, yeah, I will continue to just bring some sort of infinite series, is all obviously because I've been just taking integrals only like in front of you, but now, well, I have a lot of interest in infinite series, obviously, but because I have a deep interest in infinity, so that's why I like infinite integrals, infinite series, and all about infinity. And well, guys, I'm thinking of bringing the Ramanujan's evaluation of the infinite sum of natural numbers, that is being evaluated to negative 1 over 12. Well, guys, there are a lot of videos over that, but I will try to bring it myself. And but for now, I think everything is done, guys. Thank you so much for watching this video. Just be attached to me. You will get to know a lot of things. And my name is Aman Gupta. I'm a 12th grader student from India. But well, the answer, like the what why I said but after I introduced to you, I introduced you to like I introduced you, but then I said but after I said that I'm living in India, but then I just said but again I just said it. Don't mind. I will tell you why I said but living in India. Okay, in some sort of videos because I have a lot of issues with India, and I will try to just bring all them up in a separate video. And this is our educational like what do you call it? Educational zone, but there is another zone of me of just telling all the stuffs that are not good in India. Okay, and thank you so much, guys. I think it's just gonna be too much. Thank you so much, guys. Stay tuned.